Hi everyone, good morning. In this lecture series, we are going to discuss about the topics in clippers. Clippers are the circuits that clips off or removes a portion of the output signal. So there will be no distortion to the remaining part of the waveform without causing any distortion. The basic operation of the diode clipping circuits is such that in forward bias, the diode allows the current to pass through it, clamping the voltage. But in case of the reversed biased condition, no current will flows through the diode and the voltage remains constant. At the same time, it will not affect the terminals. So this is the definition of the clipper circuits. While coming to that of the classification of the clipper circuits is divided into two circuits. One is series clipper circuit, another one is shunt clipper circuits. The series clipper circuits is divided into series positive clipper circuit, series negative clipper circuit, series positive with biasing, as well as series negative with biasing. So these comes under your series clipper circuits. The shunt clipper circuit refers to four types. One is shunt positive clipper circuit, shunt negative clipper circuit, shunt positive with biasing, and shunt negative with biasing. This is the series positive clipper circuit. So here I'm going to apply the input signal. Here the diode is connected across the terminals, that is cathode is connected to that of the input voltage and the anode is connected to that of the resistor. So the output will be in the form of V out, that is it is taken as Vm. The same thing in case of the negative clipper, the negative portion will be clipped off. We will get only the positive thing. So here the diode, we are having anode as well as cathode. At the same time, it is connected to that of the resistor. Here the negative is clipped out. So we are getting the negative clippers circuits. So this is the series positive clipper circuit with bias in case of the positively biased circuit and the negatively biased circuit. So we are applying the input signal, the same diode is given, but there is only one difference, which is the supply gets changed. So here the positive is given to that of the anode in case of the positively biased circuit, and the negative is given to that of the anode in case of the negatively biased circuit. This is the difference between. At the same time, the negative clipper, the diode terminal, that is cathode, is given to the positive. At the same time, the cathode is given to the negative in case of the negatively biased circuit. So this is the difference between your positively biased circuit and the negatively biased circuits. The next one we are going to see about the shunt positive clipper circuits and shunt negative clipper circuits. So here we are applying the input. So here the diode has been connected. When the anode is connected to that of the resistor, here the negative, we are getting only the positive. It clips off the positive and we are getting only the negative. But in case of the shunt negative, it will clip off the negative and we will get only the positive things. At the same thing is applicable to that of the shunt positive clippers in case of the positively biased circuits and the negatively biased circuits. So this is the difference between this is the difference between the positive clipper in terms of the positively biased and negatively biased. At the same time, the shunt negative clipper, in case of the positively and negatively, just we are going to connect the power supply with the terminals. So this is dual. Just we are having two diodes, that is D1 and D2. and the voltages has been connected to that of the terminals, and finally it is given to that of the output. So these are all the assessment questions. So the circuit that has been used to produce the desired output is clipper, and the diode conducts in the positive clipper when input voltage should be equal to reference voltage. Suppose if the input voltage is higher than the reference voltage, the output voltage should be equal to that of the reference voltage. Thank you.